Hey ho and welcome to a new video regarding Visionaire Studio 5, and today I show you how to create speech bubbles in your game. Speech bubbles have the advantage that they may accentuate the text against the background so that it is more clear to read, and also it could be just a design decision from you to say, yeah, I'd like to have speech bubbles in my game, so let's do it. First of all, I want to talk about some limitations of the script. In purpose of this tutorial, I slimmed down it a little bit so that we can achieve faster results. The first thing you need to know is that the text inside this speech bubble is only left aligned. It is possible to align the text in the center for each line, but that would need to render each line separately from each other, and to make it not too complex for this tutorial, I decided to make it only left aligned for this video. So the general idea about this tutorial was to make it an easy step into a full Lua based script without any other objects to implement, and make it easy to enhance with further features. As a second point to keep in mind is that the script itself only triggers when character text is started. So there are different kinds of text you can display, but this script only will render a speech bubble when the display text action part is launched, and it only recognizes manual line breaks. So no automatic line breaks via the auto line break feature of the font. So when you have a 160 pixel wide definition for the font to have an automatic line break, the script doesn't recognize that. So to do it right in the beginning, you should only make manual line breaks and don't rely on the font feature to automatically do this line break for you. Then as a third point, the pause tags you can add to your display text will get recognized, of course, but you can't have text after a pause text. Even if it's longer than or have another size than the text before, the speech bubble doesn't get re-rendered because it only triggers for the display text action part, which was already run for that display text. So to make it right, you have to add another display text action part and put the third, it's in this case the third line in an extra action part for itself to have it rendered properly, to have the speech bubble get its new size for the new, maybe longer or shorter text. This is a thing you should keep in mind. It's not really a limitation, but you should do it the right way from the beginning to get not in trouble afterwards you use my script. So in the beginning we should do a bit of preparation work. What we don't want is to use a single image for every speech bubble we have in the game to have the exact size. We want to create it dynamically for each size of the speech bubble, for each text it could contain. So I will show you some graphics we need to create before we start making the script. So let's see, at first we have the speech bubble base PNG file. This is a 16 by 16 pixel sized file. In case of your game, you could use another size a bit larger, depends on your style. The thing you have to have in mind is that we want to slice the picture up into 9 tiles via Lua, not in the graphic program. So you see the corners here in the graphic will be used and stay the same, and the edges which connect these corners will be stretched out to get a larger speech bubble graphic so that it can fit the text inside. Then I have 2 root images, one aligned left, one aligned right. I'm not sure how this thing on the speech bubble is called properly. I called it root, but it's also maybe a pointer or something like that. So depending on the character orientation, we want to render either of these 2. back into Visionaire Studio, we need to create our script at first. We call it Speechbubble and check that it's a definition script. And now we have to think about what do we need to do. We have to get the text of a character, a spoken text. Then we need to save it somewhere, maybe in a table. We have to hide the original text because it will shine through the speech bubble if we have a translucent kind of thing. And we have to render the speech bubble for each character who speaks at one time. So it could be that there are, for whatever reason, more than one speech bubble at a time. So at the beginning, of course, this has to be a definition script, as already mentioned. And we create a table which I call bubbles. It will contain every character text which is currently spoken by one or more persons at the same time. And when the text is finished, it will, the content of this person's text will be removed. Then we make it a local variable because we only use this in our script. A second variable I call border is used to make the text render a bit off to the center of the speech bubble. So we have to add this size to the overall dimension of the speech bubble so that the text doesn't get rendered exactly on the edge of the speech bubble, but in this case 8 pixels more in. So next we need 2 more functions which get called first when a text gets shown, where in it we will determine if it's a character text and add the text to the bubbles table. And the second function is used to remove the content from the bubbles table when a text disappears from the screen. So the first function we call showBubble. And of course it has some parameter in it, but I will add it later. And the second function is destroyBubble, which also has a parameter which I will add also later. Then we need to register these 2 functions to an event handler. The showBubble function has to be added to the text started event, and the destroyBubble function has to be added to the text stopped event. So each time a text gets shown or disappears from the screen, one of the 2 functions will run and do whatever we will write in the next step. So how do these event handlers look like? It's a function which is called register event handler, and it has 2 parameters we have to add there. The first is the kind of event which triggers the handler, and the second parameter is the function we want to run when this event is triggered. So in the case of the showBubble function, we have to enter here the name of the function, which is showBubble. The same goes for the destroyBubble function. So we have to copy this over and change it to text stopped. And as the second parameter, we use destroyBubble. These text started and text stopped events are engine events, so we don't need to code them or write something else for these down. So they will work just when we write this. And as mentioned before, these 2 events also have parameters which get used by the functions now. The text which is used by the functions now is not only the text string, but it's a whole text object which contains the owner of the text and so on. We do this by checking in an if condition if the spoken text object, if the owner of this text comes from a character. And we do it by checking these a subfield of the text object which is called owner, and check if the ID via a specific function which is called getID. We check if the table ID we get back is the same as the character table where each character is stored in the engine. So the getID function here gives us 2 results. One is the table ID, which is hopefully the characters table, and only if it's a characters table, yeah, we will continue. And it also gives us the ID of the current character, so we could even limit it more to only show bubbles for a specific character, but we want to use it for, of course, every character. If the text owner is is someone from the characters table, we will continue. One thing you have to notice is that some functions, especially here, we used it already, the getID function uses a colon in front of its name, so that this function runs on the owner object we defined before and get the result out of it. So next we will add the text which is spoken to the bubbles table, and we will give it a unique ID, and this is the ID of the current active text. So we need to also use the getID function, but for the text object itself, get its ID. And in it we save of course, the text from the active text. This is also the current text in the current language, so we don't need to check further for English or French or whatever. And the second field is the owner we want to save there, but we will only save the name of the owner and not the whole owner object, so that it doesn't contain the character position, its inventory, or all kind of that. We want to only save the name, and later in another function where we display the speech bubble and its root, then we may want to get the character object back from the name, but in this case we want to save it in the bubbles table as slim as possible, so we only need the character name and the text he or she speaks currently. Then in the next step, we need to destroy the text or remove the spoken text from the bubbles table as soon as the spoken text ends after, for example, the pause tag time, or after the audio played and it's automatically discontinued by the engine. So we have to set the field where the current text is stored in. We have to set it to nil, and we also don't need to check for if it's a character text or something else, because if it's another kind of text, it won't remove anything because the field doesn't exist anyway. Then we have to edit the show bubble function again to edit the still remaining current text and make it invisible. That's the reason behind that is that it may get rendered behind our speech bubble still, so we need to clear it up, and the easiest way would be just to get the current text from the text event and set it to nothing. I don't set it to nil, but I set it to an empty string. So in this case, when the normal text gets rendered, nothing renders at all for the standard text rendering itself. The next thing we need is a function which grabs the content of the bubbles table and renders for each entry an own speech bubble for the currently speaking person. And this is done by hooking into the render process of the engine and running a function each rendered frame. So next we want to add our draw functions, and we call it bubble, and this function will handle all the rendering of our speech bubbles and the text. To hook it into the drawing process of the engine, we use the graphics object and use the method addDrawFunc. I guess it's short for draw function, and it takes two parameters. The first parameter is the function we want to run each drawed frame. So this will take the bubble function as a string, and we don't we should not forget the brackets in this case. And the second parameter is the a number which is kind of the position when to run this function. So this parameter can go from -1 to 1, and 1 means that it renders after the interfaces get rendered. And this is for us good to know, because when you use a screen filling inventory, for example, we want to render the speech bubbles above it. We don't want to first render the speech bubble and then the interface graphics, so when our character looks at an item, we can't see the speech bubble, and this should not be the case. So we use 1 as a parameter to render these bubbles at the end. Inside our bubble function, we now use a for loop to go through each entry inside the bubbles table, so that each text can be rendered separately. We do it with a key value for loop and the parse function, so that each entry inside the bubbles table can be used or called by the val value. So when I use here the val.text, I get the current text. And when I use val.owner, I get the owner name. Now, to achieve all this, we have to do some more preparation work. For example, we need to get our role character object back. We need to get our images into the script. We have to calculate the character position. That's why we need the character back in the script anyway. And we need to calculate the speech bubble dimension, so that the display text can fit inside it properly. So to do all this, we need some new variables. For example, at first we want to get back our character object itself, and of course we saved the character name, so we now can get the object of the character back by searching for its name in the characters table. So here we are using the a char variable, and in it we save the character object with the name of val.owner, which is then the saved name. And next we want to save the position, and we could do it by saving the character position and then calculating the height depending on the size of the sprite, depending on where the character stands on the scene, and how the waypoints sizing him or her. But there's also a function which already does that and gives us a position directly over the head of the saved character in this case. So this is also from the graphics object, and we use the get character text position, I guess. Yeah. And the char is the object we want to use here as a parameter, and this will give us the position above the head of the character. Then we want to save the font. We don't need to use a specific variable here. We just get the character font from his settings. And then we want to edit the current text. Because, as mentioned in the beginning, we need to manually do the line breaks. We use the gsub function to replace the br, which is the it's an HTML command, which does the line break in the editor. We want to replace it with \n, which is also a line break, but it's used in the player, in the game later. The thing is, when I change the script now and come back, you see the BR is already interpreted as, let's do a line break here, and the editor does it and removes it magically, of course. And we need to do some kind of workaround for this. And we will do it just by writing it in a separate string and tie them together. So the first thing is the BR until the slash, and then the second part is the closing bracket. And this thing we will replace with the \n. Now we can calculate the dimension of the whole text, inclusively the line breaks. And there is also a function for this in the graphics object. It's called font dimension, and as a parameter it takes the text, and together with these the defined font we did earlier, and the size of the font characters and the line spacing and everything else, it calculates two values. One is x and one is y, and this will give us these two values and say this text with this font will need this space, this width and this height. So it's good for us to stretch the speech bubble to its full dimension. So now we have to troubleshoot a bit, because the position we got from our function before to get the point directly above the head is alright, but we have to edit it a bit, because now when we want to render a graphic from that root point above the head, the graphic would render to the right of that position and downwards, so that it will not render correctly. So we have to move it to the left a bit, exactly by half of the width and above the head. So we need to correct these positions. So we have to calculate a bit. At first we have to subtract some points from the x dimension. At first the scroll position from the current scene. That's because the scene could be larger than the viewable area. And we have to calculate that into it. And then we have to subtract the half of the actual speech bubble size. So it's the x dimension from our calculated width, inclusively the border, and divided by 2 is exactly the half of the current size, so that all in all the speech bubble will get moved half the speech bubble size to the left. The same goes for the Y position, but we have to do it a bit differently here, because we want to move the speech bubble completely up by its whole size. So we have to do it a bit other. Wait, here is a typing error. Here the C is missing. We don't have to divide the whole speech bubble by 2. I tended to use or to divide the border only by 2, so that the speech bubble itself moved a bit up, but we don't need to divide the whole dimension by 2, because it needs only to grow on the top edge and not in both ways. So then when you have 2 lines, that the speech bubble only grows upwards from the root position. Additionally to that, I subtracted also 10 more pixels. That's because we want to add the root graphic or the pointer graphic to the speech bubble as well, so we need to space it a bit out some more. Then we have to build in some methods to prevent the speech bubble to render outside the visible area, because it could be that the character or an NPC stands at the edge of the screen and the speech bubble would get rendered halfway, you can't read it anymore, or it's chopped, and so we have to prevent the speech bubble to do this. So we have to check if the X position of the speech bubble is less than 0, so it touches the left side of the screen, and also prevent it to get too far to the right. And that's done by getting the window resolution, or at least the internal resolution of the game, and then subtracting, of course, the size of the speech bubble again, because you need to render it to the left from the right side, that it's still inside the screen. So to prevent it, we check the if the X position is higher than the window resolution minus the speech bubble resolution, and if it's the case, we set it at the same spot so that it still renders inside. So let's see, then game.window resolution.x minus the calculated dimension minus the border. And the same goes for the Y position. Of course, the character itself, the active character can walk mostly maybe too far to the top of the screen, so that the speech bubble needs also to get hold at the 0 position if this happens. And for the current character, it's mostly not possible to get too low, because even if the current character stands at position at the most bottom position on the screen, the speech bubble is rendered above his head. So mostly it doesn't occur that the speech bubble gets rendered below the maximum Y position, but it could be that an NPC stands below him. So we also need to do this calculation for the maximum Y position, and it's mostly the same for the Y position as for the X position. We have to set the position dot Y to at maximum, at least, to the internal game resolution minus the dimension for the speech bubble, inclusively the defined border. And there we are. Now we need to import our predefined graphics to the script so that we can render it via the render functions to display a speech bubble with our calculated dimensions above the heads of the speaking characters. To put it together, we need at first our sprite, so I create a new value, and we call it sprite, and we load in our base file, our speech bubble base. We do it via the graphics method and call the load from file function, and it includes the path to the file, and we prepend the visPath parameter to the path itself so that it gets correctly linked when we export the game later. So my sprite is located under the GUI folder. In it there is a speech bubble folder, and there I saved the prior mentioned 3 graphics, and I load the speech bubble underscore base PNG file. Then we also need a Lua value, and I call it DestRect for destination rectangle. And in this we will save our new calculated dimensions for the speech bubble. So it's a table and it contains the new dimensions. So the X position is the recalculated pos.x and the Y position pos.y. And for the width we use the dimension.x plus the border as a new size. And the same goes for the height, which is the dim.y plus the border as a size. The next value we need is the 9rect we want to calculate, and this 9rect value is to determine how we slice up the speech bubble based PNG file. As you can see here, I have this pattern which has 5 pixels to the right and to the bottom to get to the first point we need to define. And when you go 7 pixels to the right and to the bottom, we have the bottom right corner. These 2 points we have to set in here, so that the speech bubble sprite can later be split up into the correct parts. So this is also a table and needs 4 fields. The first field is the X position, which was, as mentioned before, 5 to the right and 5 to the bottom, and the width and the height is also 7 pixels. Now it's time to render the sprite regarding our predefined dimensions. So we use the draw sprite with 9 rect function. There is a special function to do this, and it takes the predefined 3 values as a parameter. So we have the sprite, which gets split up. We have to set the destination rectangle to which size it gets blown up, and we have to define at which points the sprite gets sliced up to get the bigger speech bubble graphic. Then we can multiply it with the color to color it in. In this case, I color it with white so it doesn't get changed. And the last parameter is the alpha channel, so we can make it transparent or not. In this case, I don't need transparency. The next thing is to draw the text itself. So we also have a function for that. It's called draw font, and it takes the actual text we want to render out. And as a second parameter, it will use the positions we have there. So we can use the X position plus the border divided by 2. And need also to add the scroll position for the X, X value. And the third parameter is the same as for the X, but only for the Y position. So we copy and paste it here and change the X to the Y. And as a last parameter, we can add also some kind of opacity or transparency, which is in my case 1. Last but not least, we need to render the pointer or root graphic to our speech bubble. And as mentioned before, I'd like to have a different graphic depending on where the character who's talking looks to. So at first we create the value, I call it pointer here, and then we have to use an if condition to check if the current character who is used here in this, to render the bubble, if its direction is either above 90 degrees or below 270 degrees, so that the character looks to the left. And if it's not the case, obviously he's looking to the right. Of course, you can define some more angles, but I guess these two at least would do the trick well. So when the character is looking to the left, we load in the, I copy this quickly, we load in the speech bubble root _ L PNG file, which is the left aligned graphic. And if it's the character doesn't look left, obviously he looks right, or he's aligned right, and we load the right graphic. Then we have to define the position of the graphic to render later. So it will take an X and a Y coordinate, and the X position in this case is not defined by the position we calculated earlier, but by the character position X value. That's because I want the root or the pointer graphic to be located every time above the head, independently where the speech bubble is rendered. And the Y position, of course, is the position dot Y plus the dimension of the speech bubble. Plus, here I subtracted some pixels from the border so that the graphic of the root sprite, we have it, let's see, have it here, so that it gets moved a bit up so that it's rendered above this shadow here from the speech bubbles, so that it looks like one solid piece, inclusively the pointer graphic. Yeah, and then we have to render it. We use the draw sprite function for that. It takes the pointer itself as a parameter, and all the position and so on is defined before. And the second parameter is the opacity, which is 1, so no opacity. And of course we can also define some color which get multiplied to the speech bubble. And now we can test our script. I guess we completed it very quickly, even though we used half an hour for this. I did an extra scene for this to have a wider area than the game resolution to test out. And I also prepared a key for that to display some text. So when I press it, we see some display text, as you can see. Everything rendered above, and at last we have a bigger text which gets rendered left aligned inside the speech bubble. So let me just go to the right to test out if the speech bubble clips or gets stuck to the right. As you can see, it works quite fine. The root or the point of the speech bubble is still over the head of the character, so that it's still possible to make out the current speaking character. And yeah, I think it works quite fine. So let me just walk a bit around. Let's see if the alignment of the pointer also works. I guess we already saw that. Yeah, it's facing left now here. And as you can see, it gets stuck at the top so that it doesn't render outside the viewable area. And let me just test when we walk. You will also see that the speech bubble will walk with the scrolling scene. For now and for this tutorial, I guess we are finished. You are able also to break my set limitations for this tutorial, so you can expand it to recognize centered text inside the speech bubbles. You can break the limitations to also check the automatic line break, but maybe that's some stuff for another tutorial or only for you to learn. As for now, I thank you for watching this video, and until next time.